Organizations collect massive amounts of raw data every day, including clicks, transactions, sensor readings, and more. This data has potential, but not in its raw form. Think of it like lumber or screws. It's the raw material that we will eventually turn into a chair. The challenge for data engineers is transforming this data into something valuable without duplicating someone else's work. We aren't trying to build custom furniture for each use case. Instead, we want a single reusable product design. But how can we transform our data without duplicating effort? The answer lies in how different teams approach the same data challenges. Each team has their own requirements, which leads them to different solutions, even if there are similarities between them. The finance team pulls sales data to build financial reports. They combine it with payment data to get a more complete picture. Meanwhile, the marketing team also needs sales records. They combine it with details about their marketing campaigns in order to understand their effectiveness. This is where we get into building custom furniture. Each team is working in silos to solve their immediate problem. There's overlap between solutions, but because they operate independently, they build from scratch, duplicating efforts. So how do we break free from this cycle? We start by cleaning and validating data in one place. Raw data is often messy. Customers make typos in email addresses, select impossible birth dates, or miss important details in forms. Meanwhile, hardware sensors can time out or fail, resulting in incomplete or garbage data. Imagine sales records that include null values for some prices. The finance team determines that nulls should be replaced by $0. Meanwhile, the marketing team drops these records. This impacts what each team reports for sales volume and averages. The marketing team will have fewer sales with higher averages compared to the finance team. One of them is probably correct, and it's important we figure out which. Rather than each team managing their own cleaning and validation, we should establish consistent rules and apply them once. Working with domain experts, a data engineer determines the correct solution to handle bad data, remove duplicates, and validate critical fields. Then they build a pipeline that creates a single source of truth. For financial records, we might decide null values should be 0 but flagged for follow-up. Now when the finance and analytics teams analyze the transactions, they start with the same clean foundation. This eliminates the situation where different teams report conflicting results. However, cleaning and validating data is only the first step. Often, data comes from multiple sources, each formatting it differently. Sometimes these differences are small. One source uses customer IDs, while another calls them user IDs. Or one uses a string for addresses, while another breaks them into multiple fields. In a more extreme case, two sources can use entirely different data formats, such as one using JSON while the other uses protocol buffers. Let's look at a simple example. Computer systems store dates in many different ways. Imagine if the main sales system uses a year-month-day format because, well, that's smart. The payment processor uses month-day-year and will try not to hold it against them. The analytics platform converts everything to Unix timestamps. There's no way to do reasonable date comparisons across these systems without first standardizing the format. Rather than duplicating this logic, data engineers should build a standard data format every team can use. Years ago, I worked on a project where we had similar data from dozens of different sources. A data pipeline translated each format into a single unified document structure. This meant dates were stored the same way regardless of what source systems were doing. Enumerated types were created to standardize values, and addresses were broken down into a consistent structure. Instead of every team building their own parsing logic from multiple sources, they had a single consistent foundation. Teams could still customize the data for their needs, but they're no longer duplicating upstream transformation work. Everyone benefits from the unified structure, even when adapting it for their own use cases. However, unifying the upstream format is only half the battle. We've already discussed that data can come from many different sources. This could include database records, calls to external APIs, log files, real-time data streams, and more. Each source provides additional context we may need for analysis. Consider sales records that include details like customer IDs, product IDs, and prices. Many use cases need more than just these basic identifiers. If we want to break down sales by geographic region, we need addresses. Or if we're interested in sales for various product categories, a product ID is insufficient. We need to combine data from multiple sources to create the necessary context to answer our questions. When teams operate in silos without access to each other's data, they're forced to pull sparse data and enrich it themselves. They write queries to join sales records with customer data, product catalogs, and geographic information. Each team ends up rebuilding similar enriched views. That's not to suggest we want every team reaching into each other's databases. The concept of microservices evolved in part to avoid headaches when everyone has access to everyone else's data. Instead, we want to enrich data once, closer to the source, so teams receive events that already contain complete context. Rather than emitting sparse sales events with just customer IDs and product IDs, we enrich them before they reach downstream teams. The sales event will contain detailed customer records and full product details, saving downstream consumers the hassle of looking up that information. That way, when the marketing team receives sales data, they already have the information they need for regional analysis. When the product team gets the same data, product categories are already included. Both teams work from the same enriched foundation instead of building their own separate enrichment logic. However, sometimes, rather than wanting more data, we actually want less. What happens when the CEO asks, "How did last month's sales compared to the months before?" When answering this question, individual customers and products are irrelevant. We don't even care about individual sales. What we need here is an aggregation. When we aggregate data, we sacrifice granularity in exchange for deeper insights. The common way to handle this is putting data into an analytics platform and then running SQL queries that perform the aggregation on demand. But just like with other scenarios we've looked at, multiple teams may need this same information. It would be valuable for the finance team, and I'd imagine the marketing team would also be interested in these same metrics. If each team runs their own queries to calculate the same data, we're once again duplicating effort. Not to mention the chaos that occurs if one team performs the calculation differently. We're back to having multiple teams providing different answers to the same basic question. The solution looks similar to when we enriched events in the pipeline with the necessary context. Here we can do the same thing and aggregate data in the pipeline. The difference is that with enrichment, we were potentially altering each individual record to contain more data. With aggregation, we want to emit completely different events that contain aggregated values. Essentially, we divide data into chunks such as hourly, daily, or monthly windows. We pre-compute the aggregates so they can be used by many downstream clients. One key benefit is that computing the aggregate no longer takes time. Typically, running an aggregated SQL query could take seconds, minutes, or longer to pull in the necessary data. Because these values are pre-computed, they're ready instantly when you need them. This makes them much more reliable and encourages teams to leverage the common data source rather than building their own version. You might notice a common thread throughout this discussion. Our solutions involve taking data that's calculated on demand and pushing it upstream so it can be reused by many teams. This can be done in a batch-oriented process. As data comes into the system, batch processes can run and create intermediate data sets for downstream consumers. These batches can run monthly, daily, hourly, or with whatever frequency is required to meet business needs. However, this frequency creates its own challenges. One part of the business may decide daily processing is suitable for their needs, but another department might need it faster. If we provide solutions using the wrong time window, we're forcing other teams to rebuild them to fit their needs. In the past, technical limitations forced us to adopt batch processes like this. However, modern tools like Apache Flink allow us to break through these barriers. We can use Flink to apply all the previous patterns in real time as events flow through the system. We can have Flink jobs that clean and validate data, emitting new data streams as they go. These can be picked up by another job where they can be restructured into a common format. Multiple streams can be combined, even pulling data from other sources to create an enriched view of records. And it supports aggregation and windowing, which allow us to aggregate all this data in real time. Everything we've discussed leads us to create something we call data products. The idea is to treat data just like we treat any product in our business. We want a reusable asset designed for consumption by multiple teams. Instead of building custom furniture every time, we're building the data equivalent of IKEA furniture. So what is a data product? Data products have 4 key characteristics that result from applying the transformation patterns we've been discussing. First, they provide a single source of truth, eliminating conflicting metrics across departments. Second, they include complete business context, giving teams all the information they need to make decisions. Third, they're easy to consume, with standardized formats teams can use immediately. And fourth, they're ready for immediate use, requiring no complex processing or additional calculations. These products get teams 90% of the way to their goal. They may need that final 10% of customization, but that's minor compared to building everything from scratch. The important thing to recognize is that good data engineering doesn't mean creating custom furniture for every use case. Instead, we must acknowledge that there are common needs across different parts of the business. Then we can stop building custom solutions and create data products that work for everyone.